Connecting the electrical grounding conductor, or EG, to the water pipe in a Class 1 Division 1 area can create a hazardous condition. Class 1 Division 1 areas contain flammable gases, vapors, or liquids that can produce explosive mixtures. If current is present on the EGC, it can flow through the water pipe and potentially create a spark or ignition source. This could ignite the hazardous atmosphere, resulting in an explosion or fire. To address this issue, the following measures should be taken. Firstly, use a separate grounding electrode system. Install a separate grounding electrode system, such as a buried copper grounding rod, to provide a safe and effective ground connection without relying on the water pipe. Secondly, isolate the grounding conductor from the water pipe. If the water pipe must be used as a supplement to the grounding electrode system, it should be isolated from the EGC using a dielectric bushing or other approved method. This prevents current from flowing through the pipe. Thirdly, bond the water pipe to the EGC. If the water pipe is used as a supplementary grounding electrode, it should be bonded to the EGC at the point of entry into the building. This ensures that the pipe is at the same electrical potential as the EGC, reducing the risk of arcing or sparking. Fourthly, use approved conduit and fittings. Install the EGC and other electrical components in approved conduit and fittings that are designed to maintain the integrity of the electrical system and prevent the escape of hazardous gases. Fifthly, follow National Electrical Code, or NEC, requirement. Comply with the National Electrical Code, or NEC, and local regulations regarding the installation of electrical systems in Class 1 Division 1 areas. These regulations provide specific guidelines for grounding and bonding to ensure safety. Additional considerations include the potential for corrosion on the water pipe, which could weaken the connection between the pipe and the EGC. Regularly inspect and maintain the entire electrical system, including the grounding connections, to ensure proper operation and prevent potential hazards. Train personnel who work in the area on the importance of electrical safety and the potential hazards associated with connecting the EGC to the water pipe. The NEC addresses grounding and bonding requirements extensively. The purpose of grounding is to limit voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines and to stabilize voltage to earth during normal operation. Bonding ensures electrical continuity and the capacity to conduct safely any fault current likely to be imposed. The NEC specifies that in Class 1, Division 1 locations, all wiring and equipment must be intrinsically safe, explosion-proof, or purged and pressurized. Grounding and bonding are critical to ensure that any fault currents can be safely carried back to the source, tripping the overcurrent protection device and preventing the accumulation of static electricity, which could be a source of ignition. Section 250.50 of the NEC covers grounding electrode systems, detailing the components that must be bonded together to form the grounding electrode system. These include metal underground water pipes, the metal frame of the building or structure, concrete encased electrodes, ground rings, and rod and pipe electrodes. However, it's important to note the requirements for supplemental electrodes if a metal water pipe is used as part of the grounding electrode system. Section 250.53 covers the installation of grounding electrodes, specifying the requirements for ground rods, pipes, and plate electrodes. These electrodes must have at least 8 feet of contact with the soil. The code also addresses the use of concrete-encased electrodes used for grounds, which must be at least 20 feet of bare copper conductor encased in concrete. Section 250.64 outlines the requirements for grounding electrode conductors, specifying the acceptable materials, sizing, and installation methods. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus or terminal within the service equipment. Section 250.92 covers bonding of metal enclosures and other metal parts. This is crucial in hazardous locations to ensure that all metal components are at the same electrical potential, minimizing the risk of arcing or sparking. The NEC provides specific requirements for equipment grounding conductors, outlining the acceptable types of conductors and their sizing based on the rating of the overcurrent protective device in the circuit. In hazardous locations, it is essential to use appropriately sized equipment grounding conductors to safely carry fault currents. Section 501.30 addresses grounding and bonding in Class 1, Division 1 and 2 locations. It requires that all raceways, boxes, and fittings be bonded to ensure electrical continuity. Additionally, it mandates the use of threaded metal conduit or listed fittings with threaded buses for connection to enclosures. This section also emphasizes the importance of using explosion-proof equipment and wiring methods in Class 1, Division 1 locations to prevent the ignition of flammable atmospheres. The NEC requires that all equipment in Class 1, Division 1 locations be approved for use in such environments. This includes explosion-proof enclosures, intrinsically safe systems, and purged and pressurized systems. Explosion-proof enclosures are designed to contain any explosion that may occur within the enclosure, preventing it from propagating to the surrounding atmosphere. Intrinsically safe systems are designed to limit the energy available in the circuit to a level that is below the ignition point of the hazardous material. Purged and pressurized systems use positive pressure to prevent the entry of flammable gases or vapors into the enclosure. Proper maintenance and inspection of grounding and bonding systems are essential to ensure their continued effectiveness. Regular inspections should be conducted to identify any signs of corrosion, loose connections, or other damage. Any issue should be promptly addressed to maintain the integrity of the grounding system. The use of corrosion-resistant materials and coatings can help to extend the lifespan of grounding components, especially in harsh environments. Proper training for personnel working in hazardous locations is crucial to ensure that they understand the importance of grounding and bonding and the potential hazards associated with improper installation or maintenance. Training should cover the specific requirements of the NEC and other applicable standards, as well as the proper procedures for inspecting and maintaining grounding systems. Ignoring these requirements can lead to serious consequences, including explosions, fires, and electrical shocks. Therefore, it is essential to prioritize electrical safety and adhere to all applicable codes and standards. When upgrading electrical service in a Class 1, Division 1 location, special attention must be given to maintaining the integrity of the grounding and bonding system. The installation of new equipment or wiring should be performed by qualified personnel who are familiar with the requirements for hazardous locations. All new components should be approved for use in Class 1, Division 1 environments, and the grounding and bonding connection should be carefully inspected to ensure that they are properly installed and tightened. In some cases, it may be necessary to install additional grounding electrodes or upgrade the existing grounding system to meet the increased demands of the new electrical service. A thorough review of the existing grounding system and a load calculation should be performed to determine if any upgrades are necessary. The NEC provides detailed guidelines for sizing grounding conductors and selecting appropriate grounding electrodes based on the size of the electrical service. In addition to the NEC, other standards and guidelines may apply to grounding and bonding in Class 1, Division 1 locations. These may include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the International Electrotechnical Commission, or IEC. These standards provide additional guidance on topics such as surge protection, grounding system design, and electromagnetic compatibility. It is important to consult all applicable standards and guidelines to ensure that the grounding system is designed and installed in accordance with best practices. Selection of appropriate materials for grounding and bonding components is also critical in hazardous locations. Materials should be corrosion resistant and compatible with the environment in which they will be used. Copper is a commonly used material for grounding conductors due to its excellent conductivity and corrosion resistance. However, in some environments, such as those with high levels of sulfur or other corrosive substances, it may be necessary to use alternative materials such as stainless steel or coated copper. All grounding and bonding connections should be made using approved methods and hardware. Connections should be clean, tight, and free of corrosion. The use of improper connection methods or hardware can compromise the integrity of the grounding system and increase the risk of electrical hazards. Periodic testing of the grounding system is recommended to verify its effectiveness. Ground impedance testing can be used to measure the resistance of the grounding path and identify any potential problems. Testing should be performed by qualified personnel using calibrated equipment. The results of the testing should be documented and used to identify any necessary repairs or upgrades. The use of a separate grounding electrode system is often the most effective way to address the potential hazards associated with connecting the grounding conductor to the water pipe in a Class 1, Division 1 location. A separate grounding electrode system provides a dedicated grounding path that is independent of the water pipe. This eliminates the risk of current flowing through the water pipe and creating a spark or ignition source. The separate grounding electrode system should be installed in accordance with the requirements of the NEC and other applicable standards. The grounding electrodes should be located as close as practical to the equipment they serve and should be bonded together to form a single grounding electrode system. In some cases, it may be necessary to use multiple grounding electrodes to achieve the required grounding resistance. If the water pipe must be used as a supplement to the grounding electrode system, it should be isolated from the grounding conductor using a dielectric bushing or other approved method. A dielectric bushing is a non-conductive fitting that is installed between the water pipe and the grounding conductor to prevent the flow of current. The dielectric bushing should be rated for the voltage and current levels that are likely to be present in the grounding system. The installation of a dielectric bushing should be performed by qualified personnel in accordance with the manufacturer's instructions. If the water pipe is used as a supplementary grounding electrode, it should be bonded to the grounding conductor at the point of entry into the building. This ensures that the pipe is at the same electrical potential as the grounding conductor, reducing the risk of arcing or sparking. The bonding connection should be made using approved methods and hardware. The bonding conductor should be sized in accordance with the requirements of the NEC. The location of the bonding connection should be carefully selected to minimize the length of the bonding conductor and to provide a direct path for fault current. The use of approved conduit and fittings is essential to maintain the integrity of the electrical system in Class 1, Division 1 locations. Conduit and fittings should be explosion-proof and designed to prevent the escape of hazardous gases. The conduit system should be properly sealed to prevent the entry of moisture or other contaminants. All conduit and fittings should be installed in accordance with the manufacturer's instructions and the requirements of the NEC. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical systems. The NEC provides specific guidelines for grounding and bonding in Class 1, Division 1 locations. Compliance with the NEC is essential to ensure the safety of personnel and property. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. The NEC is available for purchase from the National Fire Protection Association or NFPA and other sources. In addition to the technical requirements for grounding and bonding, it is also important to consider the administrative requirements. These requirements may include obtaining permits, submitting drawings for review, and performing inspections. The administrative requirements vary depending on the jurisdiction, so it is important to check with the local authorities to determine the specific requirements that apply. The cost of grounding and bonding in Class 1, Division 1 locations can vary depending on the size and complexity of the electrical system. However, the cost of proper grounding and bonding is a small price to pay compared to the potential consequences of an explosion or fire. It is important to budget adequately for grounding and bonding when planning an electrical installation in a Class 1, Division 1 location. The potential for corrosion on the water pipe should be considered when designing and installing a grounding system. Corrosion can weaken the connection between the pipe and the grounding conductor, which can compromise the integrity of the grounding system. Corrosion can also lead to leaks in the water pipe, which can create a safety hazard. The water pipe should be inspected regularly for signs of corrosion. If corrosion is present, the pipe should be repaired or replaced. The grounding connection should also be inspected to ensure that it is still secure and effective. Regularly inspect and maintain the entire electrical system, including the grounding connections, to ensure proper operation and prevent potential hazards. Inspection should be performed by qualified personnel using calibrated equipment. The results of the inspection should be documented and used to identify any necessary repairs or upgrades. Maintenance should be performed in accordance with the manufacturer's instructions and the requirements of the NEC. Train personnel who work in the area on the importance of electrical safety and the potential hazards associated with connecting the grounding conductor to the water pipe. Training should cover the specific requirements of the NEC and other applicable standards. Training should also cover the proper procedures for inspecting and maintaining grounding systems. Personnel should be trained to recognize the signs of corrosion, loose connections, and other problems. Personnel should also be trained to respond appropriately in the event of an electrical emergency. In conclusion, connecting the electrical grounding conductor to the water pipe in a Class 1, Division 1 area can create a hazardous condition. To address this issue, it is important to use a separate grounding electrode system, isolate the grounding conductor from the water pipe, bond the water pipe to the grounding conductor, use approved conduit and fittings, follow National Electrical Code or NEC requirements, consider the potential for corrosion on the water pipe, regularly inspect and maintain the entire electrical system, including the grounding connections, and train personnel who work in the area on the importance of electrical safety and the potential hazards associated with connecting the grounding conductor to the water pipe. By following these guidelines, it is possible to ensure the safety of personnel and property in Class 1, Division 1 locations.